So today we're going to be talking about image processing. And what our goal is going to be is to have a cup that has sediment in the bottom of it and be able to drop the tip of a pipette to be able to take a sample and then remove it. So to do this, we're going to set up a structure that looks similar to it, sort of get the basics of the coding, and then we can work with a true image later on. And so I have a rectangle that I'm working with. My brown square would be my sediments, and then the pipette we're going to mark somehow to where we can move it up and down to be able to record the distance between the two. Let's open up Matlab and take a look at it. What I've got going off at that is I'm going to be working in sections, so you notice as I click through this, that's only highlighting a certain area, and that's going to allow me to run one section at a time. In other words, if I'm going to have to pause for 8 seconds for this camera to warm up, I only want to run that one time so I don't have to worry about it. And so this is actually a real-time view of what's going on in the camera, and so you can see that is within Matlab, which is easy to work with. So I do take a snapshot of it, so that way if I ever need to go back to it and reference it, I'm able to do that. And I can see that distance B is what I'm naming it, and so if I go into it, I can see distance B as a JPEG. And thus, if I leave that current location or I have to change my lighting or anything like that, at least I've got my initial image to work with. Once I have that, I'm going to clear out my image and bring it back in, and that way in future iterations I'm going to start on line 16 and work with my code because it's bringing in that exact same image right there. I'm going to bring in my image tool. The first way I'm going to do it is I'm just going to hover over different spots, see where I'm at as far as location. And so if I go right there, I can see that I am in the X and Y coordinate and that this is my 290th column and 86th row. This is my 433rd column and 330th row. I'm going to record those in Excel so I can use them to make decisions later. So then I can take that, I can take the rows and columns that I've determined, and I can take everything else and I can just section that down for what's going on. The reason we have the colon here is because it is still an RGB image, and so it's going to have a layer for the red, a layer for the green, and a layer for the blue. Once it's there, we're going to split the image so that we have an image that is red, image that is green, image that is blue, and we're going to see that on our planes. So let's run that section. Alright, so I've got my red plane, I've got a green plane, a blue plane, and then I've got my original. And what I'm looking for in this is I'm looking for the one that has the largest difference between the images that I need and the background. Because what's going to be ideal is if I can say, hey, anything that's darker than this is something we want to keep, anything that's lighter than this is something we need to get rid of to make it work. And I'm going to choose the green just because it looks like these two are much darker than my background, whereas the red looks a little bit closer. The blue looks closer with this yellow here. I'm going to run this on just my green, so my image tool there, and I can see the pixel location and then also the intensity. So in other words, to what level is it green or what level is it not. Take readings from multiple locations with the image and then record them down in hopes of setting a good threshold for this image. So knowing that everything I need to keep is below 50 and everything I need to get rid of is over 100, I'm going to start my threshold at 75 and I'm going to divide it by 255, which is my full range of color, giving me 0.294 for where my threshold needs to start at as being set. I then run this code right here, which is going to take values and either set them to be 1 or 0, and depending on which way they're on the threshold. And so this is the image I'm bringing in. This is my threshold. What I'm seeing is actually an inverted value. And so I put this little tilde in front of my image to set it to my black and white. I can also go through and I can increment the values. So I've got it set here to be 0.1, and I can slowly lift it up and see that my image is changing, and I can slowly go down and try to get as clean of an image as I possibly can. Once that image is in place, I need to make sure that I have recorded positions for where I believe my box is going to be in the image, and also the circle. So I'm just getting the quadrants for it and then recording it down along with my diameter so I can be knowledgeable about what I'm looking for. What I'm going to have to use is a bounding box, and so I'm going to show my image. I'm going to go in, find some regional properties of that with bounding boxes, and really what it's doing is it's just looking for all the full white areas. And so I can run that section, and so it's saying, hey, here's one and here's one, and then this code down here, what it's doing is it's taking those individually. And so if I go into my images BB boxes, I can look and see that They're actually small arrays where it's giving me different values that I can work with. And I'll need to figure out what these values are. It's typically the top left position and then the height and the width of the object. Then what's going to happen is we're just using an index to be able to pull out those values and then make a line between those, which is where we're getting this red line from. I'm then going to determine distances, and so I'm going to pull out those values again, and we're going to record values for the top of the ball and the height of it so I can determine the bottom. I'm then going to pull out the top of the box so I can calculate and get my distance in pixels, which I'm then going to convert down to centimeters. It's a visual of what's going on, so I'm getting my distance for the top of my box, which is my purple line here, and I'm subtracting out the height to the top of my ball and the height of my ball. I can then sit there and I can convert that into centimeters by going in and taking my reference image, which is my 5 centimeter by 5 centimeter square that was yellow in the initial image, and then knowing that I can convert that into pixels. So I can go in, measure the 24.1 and set it equal to, and then develop my conversion from that. The last thing I'm going to do is I'm going to show my image. I'm going to bring in my bounding boxes, right? I'm going to title it with the variable that we found, and then also centimeters above, and it should give me an image that looks like this. You'll notice that I did show the first original image, which has true colors, and we're doing all our math with our green, but it makes it look a little bit nicer.
An additional fun thing we can do is we can put the code within a loop so it will update in real time and sort of show the location of that dot as it moves throughout the image. Have fun with it.